Alright, so today we're going to be learning about special right triangles. Normally with right triangles you need two sides in order to figure out the third with the Pythagorean theorem. Special right triangles are certain right triangles where we could figure out all three sides if we're given a single side. So the first one we're going to look at is a 45, 45, 90 triangle. This is a triangle whose two smaller angles are 45, and it's also still a right triangle. So when you hear these numbers, it's just referring to this triangle with these specific angles. Now, for these triangles, we're always going to be able to say the legs are going to be equal to p, and the hypotenuse is going to be equal to p root 2. So essentially, p is a variable we're going to put into the problem. That's going to make it a little bit easier to work with. But because we're putting it into the problem ourselves, p can't be in our final answer. So I'm going to take this triangle we have up here, the p, and p root 2, and just put it on the bottom of the screen. So if you notice here, the p's are across from the two small angles, and the p root 2 is across from the big angle. So when we see a problem, like number 1 here, we could see it's a right triangle, and we see one of the angles are 45. So if one of the angles is 45, we're going to be able to say the other angle is 45 as well. That's because 45 plus 45 plus 90 comes out to 180. So we know it's a 45, 45, 90 triangle. Now what we do is we put in our p variables. So across from the 45-degree angles, we're going to write a p next to those side lengths. And across from the 90-degree angle, we're going to put a p root 2. Okay, so now that we put the p values down, what we do is we take our known side, which in this case is the 8, and that just means the side that we know the length of. It's not going to have a letter with it. And we take that side and we use it to figure out what p is. So whatever letter we put there, in this case it's just a p, we could set it equal to the given side, the known length. So in this problem, p is going to be 8. So now that we figured out what p is, we could use that and plug it back in to get x and y. So on the top here, if x is equal to p and p is equal to 8, we can just say that x is equal to 8. On the bottom here, y is equal to p root 2. So we just make the p an 8, and we get 8 times the square root of 2. So just like that, we figured out what x and y are. And I'm going to get all this back up on the screen, but I just want to show you what our answer kind of means. In this case, it means x has a length of 8, y has a length of 8 root 2. So using just one side of this triangle, we were able to figure out the lengths of the other two sides. All right, so now on to number 2. First things first, we write our letters on each side. So across from the 45s, we put p. The hypotenuse across from the 90-degree angle, we put p root 2. If you want to put an equal sign here, you can. It might help you out later. So now we can see y is equal to p root 2 is equal to x, and most importantly, 25 is equal to p. So this one's also nice and easy. Now we just go back and we replace p in the other letters with 25. So for y is just p, y is going to be 25. X here is p root 2, so x is just going to be 25 root 2. And just like that, we figured out the length of all three sides. All right, so the last one's going to be a little bit tougher, but it's the same steps. First, you put down all the letters. So p root 2, p, and p. And you know this because across from the 45s are p, and across from the 90s, p root 2. Now, what makes this one tougher is our known side is 19 isn't just equal to p, it's equal to p root 2. So now we actually have to solve an equation. So in this case, 19 is equal to p root 2. How do you solve for p here? Well, you have to divide both sides by root 2. So you do that, and you get p is equal to 19 over root 2. Now, some of the more astute among you might notice that, oh, we have a root 2 in the bottom here. We can't end with the square root in the bottom. So what we have to do is we have to multiply the top and bottom by the square root of 2. The top just turns into 19 times root 2. And the bottom, root 2 times root 2 is root 4. Because you could multiply the numbers together. And then you simplify the square root. Root 4 is just 2. So P is going to be 19 root 2 over 2, which is ugly, but it works as the answer. So now to get what x is just P. So x is 19 root 2 over 2, and y is also 19 root 2 over 2. And we have our answer. All right, so the first type of right triangle we saw was a 45, 45, 90 triangle. The second type is going to be a 30, 60, 90 triangle. So that just means the angles are 90 degrees, 60 degrees, and 30 degrees. In this case, we're going to do the same method with the P. The ratios are just going to be different. So across from the 30 is P. Across from the 60 is P root 3. And across from the 90, or the hypotenuse, is going to be 2P. So the shorter leg, which is across from 30, is P. The longer leg, which is across from 60, is P root 3. And the hypotenuse is just 2P. And once again, this triangle on the bottom here won't leave your screen, so you'll be able to see that for the rest of the video. All right, so some problems. It's going to be the same method as before. So first thing to notice is we only know this angle is 60. If it's a right triangle and we know one of the angles is 60 or 30, we could always get the other one to be 30 as well. That's because they add up to 180. So we get that, and then we could put in our ratios. So across from the 30 is P, across from the 60 is P root 3, and across from the 90 is 2P. And if you want to put the equal sign here, you can. So now we're going to do the same thing. We're going to take our known side. So x and y are letters. We don't know them, but 5 is a number. So we know this bottom side has a length of 5, which means we could use it to figure out what p is. In this case, p is just 5. So that means y is going to be 2 times 5, which is 10. And x is just going to be p times root 3, which is just 5 times root 3, because p is 5. Number 5 is a similar thing. Feel free to try it on your own. Then I'll put the work up here. All right, so here's the answer to number 5. Hopefully you got this. Number 6 is another one you could try on your own. Just keep in mind that nothing is going to be equal to p in the beginning. So we're going to have to do a little bit of work to figure out what p is. The last example I want to show you comes from number 19, and this is where we combine multiple triangles. If you notice on the top here, we have a right triangle, and on the bottom we have a second right triangle. The top one's 30, so it's going to be 30, 60, 90. And the bottom one is a 45, so it's going to be 45, 45, 90. If you have one angle in a right triangle, you could fill in the other. So even though there's more going on here, it's going to be the same thing. The only thing we have to notice is the top triangle is a little bit nicer because we know one of the sides. We know that side has a length of 9. The bottom triangle, we don't know anything though, so we can't use it just yet. So for the top triangle, we put down our p's. So across from the 30 is p, across from the 60 is p root 3, and across from the 90, or z, is going to be 2 times p. So in this case here, because p is 9, we could get z is going to be 2 times 9, which is 18. And this kind of middle side is going to be 9 root 3. So put in our answer for z right here. And now what we have to do is do it again, but this time for the bottom triangle. The bottom triangle, we have a 45, 45, 90. And we know that the hypotenuse, or the diagonal side in the middle, is 9 root 3. Now we can do our p method again, but this time the p value is going to be different. And if you want to use p again here, you can, but I'm just going to use q just because we already used p in this problem. So our hypotenuse is q root 2, and our sides are q and q. So we could use this top equation set 9 root 3. And set 9 root 3 equal to q root 2. So when we divide to get q by itself, we get q equals 9 root 3 over root 2. But we can't have a square root on the bottom, so we have to multiply by root 2 on the top and root 2 on the bottom. The bottom turns into root 4, which just turns back into 2. The top, we could actually multiply the insides, the 3 and the 2, to turn into root 6. So in this case, q is 9 root 6 over 2, and q is also equal to x and y, because they're the sides of the 45, 45, 90. So with that, we get our answer, 9 root 6 over 2 for x, for y, and then 18 for z.